What if I told you that time had a starting line? That everything, every star, every galaxy, every atom in your body exploded into existence from a single, unimaginably dense point, and that before that moment there may have been nothing? Or maybe something so strange, so beyond our comprehension, that even the word before starts to fall apart. This is the mystery at the edge of physics. What happened before the Big Bang? For decades, scientists believed the Big Bang was the ultimate origin story, the beginning of time and space. But in recent years, bold new theories have started to challenge that idea. Some suggest the universe is part of an endless cycle. Others propose it's one of countless worlds floating in a vast multiverse. And some argue that asking what came before is like asking what's north of the North Pole. It just doesn't make sense. So what do we actually know? What can science tell us about what, if anything, came before the birth of our universe? Let's explore 4 mind-bending possibilities that stretch the limits of physics, time, and imagination. Theory 1. The quantum origin. Let's begin by stepping outside everything you know, not just outside your home, your planet, or your galaxy, but outside space itself, outside time, outside the laws of physics as we currently understand them. It's not just a place we can't reach, it's a state we can barely imagine, and yet, it may be where everything came from. The question is simple: what came before the Big Bang? But the answer may require us to completely abandon our common-sense notions of reality. See, we live in a world where things make sense. You drop a ball, it falls. A match strikes, it lights. There's cause, then effect, past, then future. We live in the comfort of clocks and calendars, guided by rules we think are universal. But at the deepest level of reality, those rules begin to fall apart. This is the realm of quantum mechanics. In the quantum world, particles don't behave like little billiard balls. They act more like waves of possibility, flickering between states, appearing and disappearing, teleporting through barriers. Reality at this level isn't fixed. It's a shimmering cloud of potential, governed by uncertainty, randomness, and probability. And it's here, in this strange, flickering realm, that one of the boldest theories about the origin of the universe begins. The idea is this: before the Big Bang, there may have been no space, no matter, and not even time. Instead, there was something known as the quantum vacuum. But don't let the word vacuum fool you. This isn't empty space. This is deeper than emptiness. This is a sea of nothingness. That isn't really nothing. In quantum field theory, even nothing can be filled with activity. Tiny fluctuations, bursts of energy, can spontaneously erupt and vanish. Particles can appear out of nowhere, hover into existence for a moment, and disappear again, all without violating the laws of physics. It's not just theoretical. We've seen this happen in particle accelerators and quantum experiments. It's real, it's measurable, it's wild. Now imagine that happening, but on a cosmic scale. One day, in this chaotic quantum landscape, a fluctuation doesn't just pop and fizzle away, it crosses a threshold. It becomes stable. For reasons we still don't fully understand, it tips into a runaway expansion. It inflates, and in that instant, it becomes everything. This is what some physicists believe the Big Bang was. Not the beginning of something from a divine spark, or a singularity erupting into existence, but the result of a quantum fluctuation reaching critical mass and unleashing the raw fabric of reality. And with it came time, space, energy, the four fundamental forces, the raw ingredients for matter, for stars, for life, for you. But here's the truly mind-bending part. If time itself began in that moment, then the word before might not mean anything. Just as there's no direction north of the North Pole, there may be no before the Big Bang, because time didn't exist to begin with. You might imagine the Big Bang as a firework in the sky. But it wasn't an explosion in space. It was the creation of space itself. The firework didn't go off somewhere. It became the somewhere. And if the laws of quantum mechanics allowed one universe to emerge from this strange quantum nothingness, why not more? In fact, some versions of this theory suggest that universes may be bubbling into existence all the time. Most blink out. But some, like ours, inflate, evolve, and expand for billions of years. In that view, the Big Bang wasn't unique. It was just our turn. And what's even more humbling is that this entire process may not have a purpose or a goal. It may not require a creator or a trigger. It just happens, because in the quantum world, anything that is possible, however improbable, will eventually occur. This idea that our universe is the result of a quantum fluctuation is still just a theory. We can't observe it directly. We can't rewind the universe back to the moment of nothingness. But it's not a shot in the dark either. It's grounded in real science. The mathematics of quantum field theory support it. The behavior of particles we observe today echoes it, and many cosmologists believe it could one day help us unify quantum mechanics with general relativity, to finally merge the physics of the small with the physics of the large. So what came before the Big Bang? Maybe nothing in the way we understand it. Maybe a restless ocean of possibility. Or maybe a truth so deeply woven into the laws of reality that our current minds can barely grasp it. But thanks to quantum theory, we now know this. Nothing might not be empty. It might be pregnant with potential. And from that potential, a single, random, unstoppable fluctuation may have created everything. Everything we know, everything we see, everything we are, and maybe, just maybe, it could happen again. Theory 2. The Cyclic Universe. What if the story of our universe is not a story at all, but a song? Not a single note played once and fading away, but a melody that repeats, timeless, eternal, cyclical. What if everything we know, space, time, matter, life, death, even consciousness, is caught in a loop so vast, so slow, so beyond comprehension that we've mistaken it for a straight line? This is the idea behind the Cyclic Universe, a theory that challenges the traditional narrative of the Big Bang as the absolute beginning and proposes instead that our universe is one movement in a never-ending cosmic dance, a dance of expansion and collapse, creation and destruction, death and rebirth. Let's start with what we see. The universe is expanding. We've known this since the 1920s, when Edwin Hubble observed that distant galaxies are rushing away from us. The farther away they are, the faster they move. Not because they're traveling through space, but because space itself is stretching. The universe is getting bigger, not into anything, not within a container. Space is expanding everywhere, all at once. And if it's expanding now, we can imagine rewinding that expansion. Galaxies drawing closer, space contracting, temperatures rising, until everything converges into a single, infinitely hot and dense point. The Big Bang. The beginning of time as we know it. But is that really the beginning? Or is it just where our cycle happens to start? Because here's the thing, expansion doesn't have to go on forever. Yes, right now the universe is flying apart faster and faster, thanks to a mysterious force we call dark energy. But what if dark energy isn't constant? What if it weakens over time? What if gravity, the same force that pulls apples from trees and binds planets into orbits, slowly begins to win? Then the story changes. In that case, the universe would reach a turning point. Galaxies would slow, then stop, then begin to fall back inward. Stars would drift together, then collide. Black holes would devour everything in sight. Space itself would begin to collapse, as if inhaling after a long, slow breath out. And eventually, everything, every atom, every photon, every quantum field, would collapse into a singular point once again. A big crunch. The mirror image of the Big Bang. But not the end, because from that implosion, something astonishing might happen. A new explosion, another bang, a new expansion, a new universe. This is the heartbeat of the cyclic model. Bang, expand, cool, collapse, crunch, bang again. Endless cycles of cosmic evolution, with each new universe rising from the ashes of the one before it, like a phoenix, not once but infinitely. Some versions of this theory suggest that each cycle wipes the slate clean, a perfect reset, a universe born with new initial conditions, possibly new laws of physics. Other versions say the universe carries traces of its past lives, subtle imprints embedded in the fabric of reality, like ancient scars on the skin of the cosmos. Some physicists believe these scars might be visible, tiny anomalies in the cosmic microwave background, the ancient afterglow of the Big Bang, patterns that shouldn't be there, blurs that hint at a universe that came before ours. And yet, the cycle might go deeper still. One idea, the ekpyrotic model, based on concepts from string theory, suggests that what we call the universe is actually a vast three-dimensional brain, short for membrane, floating in a higher dimensional space. Imagine two brains, vast sheets like sails on an interdimensional ocean, drifting closer over unimaginable spans of time. And when they touch, when they collide, the energy of that impact becomes a big bang. A new cycle begins. The brains rebound, drift apart, and after another trillion years, they touch again. No singularity, no collapse, just collision, rhythm, harmony, an eternal waltz in a higher dimension. What's profound here is not just the scale of the idea, it's what it means for us, because in a cyclic universe, nothing is ever truly lost. Everything that ends begins again. Galaxies die and are reborn. Stars collapse and rise again in new constellations. The elements that once made you, carbon, oxygen, calcium, are scattered in death, but they may come together again across cycles in new forms, maybe not as you, but as something. Time itself may not be linear. In each cycle, time may begin anew. In some models, time may even run backward between cycles, a reversal we can't begin to imagine. We often think of the universe as a one-shot deal, a fragile, temporary miracle, a flame that will one day burn out, leaving only silence. But what if that's not how it ends? What if the silence itself is just the pause between notes, the breath between verses? What if our universe isn't a fragile candle, but the echo of a drumbeat that has never stopped? And if that's true, it changes everything. Because in the cyclic model, we are not witnessing the beginning of all things. We are witnessing one moment in a pattern that stretches forever. And the end of the world. It's not a tragedy, it's part of the rhythm. The fall of one universe is the rise of another. So what came before the Big Bang? Maybe another Big Bang, and another before that, and another still, stretching backward into infinity, like waves crashing endlessly onto a cosmic shore. And what comes after this universe? The same thing, a return, a rebirth, a beginning born from the ashes of an ending. And perhaps, if we could stand outside of time, above the spiral of space and creation, we'd see the universe for what it really is, a loop, a breath, a cosmic heartbeat. And it has always been beating. Theory 3, Multiverse. What if the universe, everything we know, is just a single page in a never-ending book? What if the Big Bang wasn't the beginning of all things, but just the beginning of our things? Our stars, our atoms, our laws of physics, our story? What if, beyond the boundary of what we can observe, past the edge of time and space itself, there are other stories unfolding, other realities, other universes, unseen, unreachable, but just as real? This is the multiverse, the idea that what we call the universe is not the whole of existence, but merely one bubble in a vast cosmic ocean, one speck of dust floating in a boundless storm. And if it's true, then the Big Bang was not the birth of everything, it was just a birth, one of many. Let's begin where this idea first takes root: inflation. Just moments after the Big Bang, our universe is believed to have undergone a period of extraordinary expansion. This wasn't the slow stretching of galaxies we see today. It was faster, explosive, a trillion times faster than the speed of light. This event, called cosmic inflation, transformed a subatomic speck into a universe large enough to contain everything we know. But here's the twist: in many versions of this theory, inflation doesn't end everywhere at once. It ends in patches. In some regions, inflation slows down and stops, and those regions become bubble universes like ours. But in other regions, it continues and keeps going forever. This gives rise to the theory of eternal inflation, a process where inflation gives birth to an infinite number of universes, pockets of calm forming within an ever-growing chaos, each bubble separated from the others by vast expanses of inflating space, too far, too fast, ever out of reach. In this view, our entire observable universe, 93 billion light-years across, is just one bubble, one universe among countless others, one flicker in a boundless cosmic fire. And each of these universes, they could be completely different. In one, gravity might be stronger. In another, stars might burn twice as hot. In some, chemistry as we know it may be impossible. Planets may never form. Light may never exist. But in a few, perhaps a rare few, the conditions are just right. Just stable enough, just structured enough for complexity to emerge, for stars to shine, for life to arise, for beings like us to ask questions like this one. In those rare places, and perhaps in ours, the universe isn't just expanding, it's thinking, it's feeling, it's aware of itself. But inflation is only one path to the multiverse. There's another, stranger, deeper, that emerges not from the vastness of space, but from the smallest scales imaginable, from quantum mechanics. At the quantum level, particles don't behave like tiny marbles. They exist in many states at once. A particle isn't here or there, it's here and there. Not one thing, but a cloud of possibilities. And when we observe it, we don't just see one outcome, we collapse the wave of potential into a single reality. But what if the wave never collapses? What if Instead of choosing one path, the universe chooses all of them. This leads us to the many worlds interpretation of quantum mechanics, the idea that every time a quantum decision is made, the universe splits, it branches. Every possibility becomes real, but in a separate parallel universe. In one, a photon goes left, in another, it goes right. In one world, you watch this video, in another, you don't. In one world, Earth formed, in another, it never did. This means there may be infinite versions of you, some almost identical, others entirely alien, and you don't even know they exist because they're separated not by distance but by possibility. And then there is string theory, which opens a door not just to multiple timelines or quantum branches, but multiple dimensions. In string theory, the fundamental building blocks of reality are not particles, but tiny vibrating strings, and these strings need more than the 4 dimensions we experience. They need 10, or 11, or more. In some versions of this theory, our universe is a 3-dimensional brain floating in a higher dimensional space, a space so vast and strange we cannot even imagine it. And in that higher realm, there could be other brains, other universes, like sheets of paper stacked in a book, each one unaware of the others. Occasionally, 2 brains might collide, and that collision, that unimaginable release of energy, could cause a big bang. That bang might be the origin of our universe, and when the brains drift apart again, the process continues, waiting for the next collision, the next creation. If this is true, then universes may not just appear one after another in time. They may exist side by side, neighboring realms we can never see, never touch, but which may be as real as the ground beneath our feet. The implications of the multiverse are enormous and unsettling. If there are infinite universes, then everything that can happen does happen. Somewhere. There's a universe where you made every decision differently. There's a universe where the dinosaurs never died. There's a universe where the stars never formed, where the cosmos is cold and silent. And there may be universes where the laws of logic and causality themselves are bent beyond recognition. Does that make our universe insignificant, or more precious than we could ever understand? Because out of the infinite permutations, out of the eternal branching of possibility, you are here, in this world, in this moment, watching, wondering. And maybe that's the real beauty of the multiverse. It humbles us. It reminds us how small we are and how miraculous. It suggests that our universe is not alone, but part of a greater whole, a chorus of creation echoing across infinite realities. And if the multiverse is real, then what came before the Big Bang? Maybe nothing came before. Maybe everything came before. Maybe the bang that birthed our universe was just the latest burst in an infinite, ever-growing foam of reality. And maybe, out there, other Big Bangs are happening right now, exploding into being in realms we can never reach, each one lighting up its own sky, its own physics, its own possibilities. Maybe we are not the beginning. Maybe we are not the center. Maybe we are just one universe quietly blooming in an eternal cosmic garden. Theory 4. The no-boundary proposal. We've talked about universes that cycle, universes that branch, universes that multiply. But what if the real question isn't what came before the Big Bang, but whether before even exists? What if time didn't begin with a bang or a spark or a moment? What if it didn't begin at all? This is the essence of the no-boundary proposal. one of the most profound and mind-bending ideas ever suggested about the origin of the universe. A theory developed by physicist James Hartle and the legendary Stephen Hawking. A theory that doesn't just rewrite the timeline of the cosmos, it removes the timeline altogether. To understand it, we need to rethink what we mean by time itself. In everyday life, time feels like a line. One direction, past to future. A straight path from what was to what is to what will be. It's how we mark change, motion, memory. It's built into everything we know. The planet's orbit. We grow older. Stars burn and die. Time is the backdrop of existence. But time, like space, is part of the fabric of the universe, not something that exists outside of it. According to Einstein's theory of general relativity, space and time are woven together into a single structure, space-time. And this structure is dynamic. It can bend, stretch, twist, and in extreme conditions, even break down. One of those extreme conditions? The very beginning of the universe. At the moment of the Big Bang, or rather the moment we call the Big Bang, the density of energy, matter and curvature becomes so extreme that our normal understanding of space and time breaks down completely. The equations of physics stop working. Singularities form. Infinity shows up in places it shouldn't. But Hartley and Hawking proposed something radical. Maybe the problem isn't the physics. Maybe the problem is how we're thinking about time. In their no-boundary model, time and space don't begin in a sharp, sudden explosion. Instead, they emerge smoothly, like the surface of a sphere. Just as the Earth doesn't have a sharp edge at the North Pole, but gently curves from latitude to latitude, the universe may not have a sharp beginning point at all. Time, in this model, is finite, but without a boundary. It's not eternal, but it also never truly starts. Imagine trying to ask, what's north of the North Pole? It sounds like a valid question, but it doesn't make sense. The North Pole isn't a point on a line. It's the end of direction. There's no north beyond it. Now imagine asking, what came before time? According to the no-boundary model, there's no before. There's only the gentle curve of space-time rising into being. In this model, time begins as imaginary time, a mathematical construct in which time behaves more like space. No direction, no ticking clock, no sequence of events. Just a smooth geometry, a four-dimensional surface that gradually transitions into the familiar time we know today. It's not easy to visualize. It's not supposed to be. We're stepping outside the realm of human intuition and into a domain shaped by pure mathematics and the edge of physical theory. But the core idea is breathtaking, that the universe doesn't need a cause, a trigger, or a moment of creation. It simply is, without edges, without boundaries, without the singular bang we imagine. It doesn't explode into existence. It unfolds, slowly, smoothly, inevitably. The no-boundary proposal does more than solve mathematical problems. It dissolves philosophical ones. It suggests that the question of what came before the universe may be as meaningless as asking what lies outside of space or what color is beyond red. It also avoids one of the biggest challenges in cosmology. If the universe had a beginning, what caused it, and what caused that? It's an infinite regress, a hall of mirrors stretching backward forever. But if time has no boundary, no edge, no origin point, then maybe we don't need a cause. Maybe the universe doesn't need a reason to exist. It simply does, and it always has. Not in time, but in geometry. Not in sequence, but in structure. There's a strange beauty in this idea. It removes the violence of a sudden creation and replaces it with elegance. Instead of a universe that bursts into being from a singularity, we have a universe that gently curves into existence, like the dawn creeping over a horizon that has no edge. It also humbles us, because in this view we're not standing at the beginning of time. We're somewhere in the middle of a much larger structure, one that may not have a beginning or end at all. And yet, we're still here, conscious, aware, capable of pondering the impossible. So what happened before the Big Bang? According to the no-boundary proposal, nothing and everything. Because time itself, the very idea of before and after, is part of the universe. It didn't exist before the bang. It emerged with it, like space, like energy, like us. And maybe, just maybe, the universe didn't begin from something. It began as something. A smooth, boundaryless shape in the fabric of reality, containing all that was, is, and ever will be. Not a bang, a bloom. We've travelled across theories, through particles and probabilities, through cycles and collisions, through dimensions we cannot see, and boundaries that may not exist. Each theory offers a glimpse into the question that has haunted us since we first looked up at the night sky. Where did all this come from? Maybe the universe was born from a quantum fluctuation, a sudden burst of something from nothing, not caused, but allowed by the laws of physics themselves. Maybe it wasn't the first. Maybe it was the latest in an infinite chain, a universe rising and falling like breath, like tide, like heartbeat, over and over again. Maybe our Big Bang is just one bubble in a boundless foam, one universe among countless others, each with its own laws, its own time, its own possibilities. Or maybe the question before is the illusion, and time itself, like the surface of a sphere, has no edge. Maybe the universe didn't begin. Maybe it just curved into existence. These aren't just competing ideas. They're expressions of a deeper truth, that we are standing at the edge of knowledge, peering into a realm where physics becomes poetry, where math becomes myth, where logic brushes against mystery. And yet, despite all we don't know, or maybe because of it, the fact remains, we are here. We are the product of stars, of dust, of forces and fields and chance. We are the voice of the universe turned inward, asking itself what it is. We are not separate from the cosmos. We are the cosmos, in human form, momentarily self-aware. We may never know what came before the Big Bang, but we know this. Wonder survives the question, and curiosity is its own form of creation, because perhaps the most miraculous thing about the universe is that it made something that could ask and keep asking.